Hello and welcome to episode 104 of Linux Dev Time. I'm Joe.
I'm Amleth.
I'm Kevin.
And I'm Andy.
Good to talk to you all again. Amleth, you've got a question for us.
How do you work within particularly painful code bases and leave them better than you found them? What are some techniques you can use to improve as much as possible? When do you rewrite particular components, refactor, all that kind of stuff?
So I'd say step one is probably to identify like the actual areas of pain and then be able to make those areas like deterministic, whether you do that by codifying them with a test or finding something along those lines. But once you find it, then you can actually measure what is the pain point of it. Is it too slow? Is it too buggy? Is there something that's happening? And then at that point, you have like something measurable that you can actually try and fix.
It partly depends how much you know the code, right? So in some code bases, you know the code, you know the bit you hate, in which case it's a different approach. But if you don't know the code and you just know that it's painful, then it might be worth, like Kevin made me think with what he was saying, that it might be worth using some techniques to find which bits of the code you even need to think about, right? So one way to do that is to look at the Git history and see which bits change often. And there are tools that can tell you some statistics about which files change a lot and stuff like that. So that might help with just getting an idea of what's going on. The kind of general thing that I would say in any difficult code base, or really any difficult project that a human does, is just try and find the smallest possible step you can that makes a step forward. So when you were talking, Amaryllis, about making the code better when you leave it than when you entered it, a key thing for that is finding a small step that you can take, a little thing you can do that makes it a bit better. And if you add a few of them up, things start looking up immediately. Not least because you've got your head around it a bit more, so you have a better idea what the big steps you might need to take to make it really better, right?
Could that be as simple as just adding some comments to it?
It absolutely could, and it definitely could be renaming some variables. When you realize what they actually do and realize that the name really threw you off, renaming functions and so on, yeah, absolutely.
Yeah, I found that it really helps to, once you find that initial entry point that is either the start of the pain or somewhere where you want to start to focus, using your editor, whichever it may be, to jump down through the code in the call site and go deep on that particular code and then pop back up, that really helps to kind of follow the code through. But you have to be very mindful of, you don't want to get sidetracked into all of the other things that the code does too. So I guess it boils down to, if you can really understand what the one pain point is, and then how to follow that thread through the code, that will really, really help you understand what is wrong or what could be improved.
Yeah, and keep it small. Don't get distracted by all the other things that are wrong. If you find the one thing that's wrong that will materially improve your life to fix it, find a way of making just that change that fixes that one thing. And then you can fix the next thing.
Absolutely. I think that's so critical. I've seen too many times where there's been a PR and someone's like, oh, I fixed this and that led me to this and I'm fixing this other thing. And before you know, you just have this monster PR where everything's intertangled and it's really hard to get out of that. So it's also really difficult to not fix the thing sometimes right away. And that's one of the reasons why I actually like a stacked Git workflow, is because you can stack different fixes for different slightly related but slightly unrelated issues with the code. You can just make a new stack and then hop back and forth between these various stacks and then reorganize them before the final set of PRs or patch sets.
Yeah, I always have like 7 branches on the go, and I wrote a little tool to look at my Git repo called gitwhat. It's like a horrible bash script. But what it does is shows me all my branches and all the different commits on the different branches. And then it makes it easy for me to visualize. So then I can just jump between, oh, I made this fix as part of this, but actually that should be a separate pull request. So I'll do that. So we can't go far into talking about legacy code without talking about the book, which has the answers to everything about legacy code, which is Michael Feathers' book, Working Effectively with Legacy Code. And Michael Feathers basically gives you all the right answers, right? So his answer is, number one, what's the definition of legacy code? And he says it's code that's not tested, because as soon as it's tested, he says you can understand it because you can read the test to see how it works and stuff like that. So his answer to like getting out of a situation where you're stuck in legacy code that you don't understand is find a way to get it tested and get it unit tested at the level so that you can understand small pieces of it. And the problem with legacy code is you can't test it because it wasn't written to be tested and it's a nightmare. The rest of the book is techniques for getting from that state of it's a big ball of mud that you can't test and you can't understand through to bits and pieces, the bits that I'm working on, are now covered by unit tests that help me understand it and help me check that I'm not breaking it when I change it. The big first step that he often talks about is you make a big test, not a unit test, but some kind of big functional test that just checks that when I make small changes to it, I haven't completely broken everything. So you just like find wherever you can test it. And he talks about finding seams, which are like areas you can get into the code as an entry point to say, this is a function that I can call where I pass in some arguments and get back an answer that I can then write a test around it without it relying on too much other stuff in the rest of the world. And that's really hard to do, but there are, different seams. Depending on your programming language, there's different types of seam. Even talks about in like C++ code bases, the linker is one of the seams. So you can like link against some test mocking library instead of against the real stuff. But any dirty way you can find to make a test that checks that you're not breaking everything. And then once you've got that test, that kind of safety harness, then you can start making small changes. Any new code you writing it in small unit tested chunks that you just call out to from the big ball of mud. And then you gradually break out chunks of the big ball of mud into nice unit tested stuff that's coded so you can unit test it. That's the like stupidly quick summary of the Michael Feathers approach.
I think an issue that I've run into when trying to do similar approaches is every once in a while I'll codify the current implementation in tests, which isn't necessarily bad, but it can make further changes slightly more difficult, as in you already know that you're going to be changing this section or perhaps refactoring a bit. So while I wouldn't say don't do that at all, because it definitely points that stuff out and it makes it front and center in your mind, I have run into issues where trying to overly test some of the things that I'm just about to change will kind of codify the actual implementation or the current implementation.
Absolutely. Yeah, that's definitely a thing you should avoid, right? Even if you can see a way of writing unit tests, if those unit tests just lock you into the way that doesn't really make sense, then it's not going to help you. Yeah, which is why like a big test that checks that the whole thing works is going to give you the safety and not give you that kind of drag of, I've got a fixed test that we're just locking in wrong behavior.
And I think that might be, you need to first understand the code, or at least attempt to understand the code, because what you're actually wanting to test is almost like the design of the code, not the implementation. You're not wanting to test the steps that it does. You're wanting to test that it does the right thing. But that requires you to already understand kind of what that piece is and what it's doing.
Yeah, also to find the seams. Yeah, basically it's hard. But I think the other thing to say is people use the word refactoring and are not always meaning the same thing by it. But when the kind of Michael Feathers type people use the word refactoring, what they're talking about is making changes that make zero difference to the behavior, external behavior of the code. Right. So all they do is change how it's done inside. So if you're doing a refactoring, you wouldn't need to change any of your tests and you wouldn't expect any different behavior at all. So I would say a big thing to remember about working with legacy code is separate out your bug fixes from your refactorings and make your refactorings as small as possible. Like literally just renaming a variable is a really good refactoring because it almost certainly won't break anything, but it makes the code easier to understand. And then while you're doing that renaming, you notice a bug, excellent. Make that a separate change. Make sure you've got a test that checks that the bug used to happen and no longer happens, and make that a separate change. And then do your next refactoring, which doesn't make any functional change at all. Keep everything small, like we were saying at the beginning.
How would you approach a situation where you could make a small local change that improves something in that one area, but maybe it makes the overall big picture a little bit more spaghetti-like and a little bit more painful? While your other option is make a much larger change that makes the broader picture nicer, but it takes a lot more time and it's not that one small isolated chunk. How would you approach deciding which of those to do?
I'm going to be a bit controversial and say it's a really easy choice, right? You make the small change and you have the final direction in mind. So you want to get to the place where everything is really better, but you find a route that takes small steps and you never succumb to that temptation, which we all have of, this is so straightforward if I just delete the world. And it's not, because you'll get lost on the way. You'll forget one of the things that was necessary. And I've done this so many times where I started down the path of, I'll just do this the right way. realized I was going wrong and went back to make small steps and found actually it's easier. Like every step I take, my tests are passing again. I can check that the thing really works, or I can make changes that are so small that I know that I haven't broken it, or like, well, you never know, right? But hopefully you have some confidence. So yeah, I would just say, yep, take the small step, but it's the step in the direction of the final vision that you have.
I don't know that that's controversial, because I would also say the same thing. I would say make the small change. And while I wouldn't want to necessarily make the code base, you know, if you said it was coupling things together or making something slightly worse in the big picture, I wouldn't want to go too far that direction. I might try and find some sort of middle ground where, like, I'm going to make the small change that I can get right now with, like Andy said, go the direction of making the overall code better in small incremental steps. And yes, absolutely avoiding that urge and that desire to just be like, oh, this would be so much easier if I started over.
I think something that Michael Feathers definitely acknowledges, and I would agree with, is sometimes you do have to make things worse on the way to things being better. So I think that example of like a weird link time thing that puts some mocks in place is a good example of, like, you would never design your system to test it that way, but sometimes you have to do a horrible thing. The trick there is not to get halfway through the horrible thing and then someone like a manager or someone tells you you've run out of time and then the horrible thing stays. So I guess a trick for that is do the horrible stuff first so that you can say, you know, I'm 50% through this task, but it's not done. And then do the like functional, useful stuff at the end, right? And then no one can stop you in the middle, hopefully.
Okay, this episode is sponsored by people who support us with PayPal and Patreon. Go to linuxdevtime.com/support for details of how you can support us too. Patreon supporters have the option to listen to episodes without ads like this. And it's not just this show. There's Late Night Linux for news, discoveries, audience input, and misanthropy, 2.5 admins about system administration, Linux Matters for upbeat, family-friendly adventures, Linux After Dark for silly challenges and philosophical debates, Hybrid Cloud Show for everything private and public cloud, and Ask the Hosts for off-topic questions from you. You can even get some episodes a bit early. We've got a lot going on, and it's only possible because of the people who support us. So if you like what we do and can afford it, it would be great if you could support us too at linuxdevtime.com/support.
How would you approach changing a core architectural approach to an application? If the core, everything is built on this being here, does not work long term and was a bad idea, how do you fix that?
Have you ever heard of the strangler pattern?
I don't think so.
My understanding of the strangler pattern is essentially, in a situation where you really need to change architecture, you make your new service or whatever, your new thing, which is architected in the right way, and you make it do a small piece of functionality, like the new thing you're working on. And then you slowly strangle the old stuff by moving bits of functionality piece by piece out of the old one into the new one. But I'd recommend looking up the strangler pattern because I'm pretty sure there's more to it. Like there's a technique that makes that possible by kind of putting one in front of the other, and I don't remember the details.
That is a horrible name, and surely not what it's called these days.
Yeah, I apologize, listener. Yeah, I'm sure it probably isn't called that these days, and it shouldn't be.
That sounds like a lot of the reasoning behind why people might adopt microservices, for example. It's easy to break a core chunk out into a microservice and then deprecate some of the other stuff.
Yeah, if you want to move all your complexity into the interactions between components, then go for a microservice architecture. Not saying that's a good decision. It sounds like that's maybe some of the reasoning behind the decision. Absolutely, yeah. And you're right. Yeah, like if your thing is a web service, then maybe you want to write your good architecture as a separate service, but probably not. Probably this pattern of making a new one alongside it and gradually moving stuff across can be done inside the service that you have.
And with that pattern too, I mean, you still really need to know the piece that you are potentially changing out. You have to really know the API and like the touch points with all the parts that are going to stay the same. So whether you codify that through tests or whatever it is, you have to be absolutely certain that that piece is not changing so that you can swap it out. Kind of like the Indiana Jones meme of swapping something over.
I joined a team years ago, this was, where we had the brand new exciting codebase that was running about 5% of our stuff. And we had the awful, everyone hates it, that was running 95% of our stuff. And both of those services were falling over daily and everything was a nightmare. And we got on top of that by wrapping tests around both of those things. Previously, the legacy system was like, this is so awful, no one can even test it. And the new system has tests, and it turns out those tests weren't that great. So we ended up with tests that tested the entire structure, both those things plugged into each other. And that was our first step, right? Get some testing around it. But the second step was, you know how everyone on the team hates the legacy system and has deliberately forgotten how it works? Or left the company because they hated it so much? Well, I'm sorry, if we're going to replace it, we have to figure out what it does, how everything works. And that's the only way, like you're saying, Kevin, the only way that you're going to successfully replace something or refactor something or change in any way, improve it, is you're going to have to understand how it works. And you're going to have to understand all those little bug fixes that made the code a bit weird. Otherwise, you're going to make those bugs again.
Another big part of understanding it, too, is the other characteristics like the performance. In fact, that's one way that you can, without just testing, that you can start to understand a code base is to benchmark it. And even just like small little silly micro benchmarks that can help you understand the code. It can give you a way to write something that uses the code, but it'll also give you something that you can look back at as you start to replace other parts to see, is it staying the same as you want it to? Are you increasing the performance, decreasing the performance? Those are also metrics that I would say a lot of managers like to see, whether or not performance is going up or down. But it's also a way that you can do this without having to just write tests around everything.
Absolutely. And there's also going to be things that you're not going to be able to predict that are going to happen to you. Like, for example, hypothetically, you're going to have a horrific outage and you're going to realize why the legacy system has a custom written DNS client.
The phrase technical debt has not come up yet, but it sounds to me like that's what you're saying. Pay off that technical debt first before introducing any more.
Maybe. I mean, I think maybe what we're saying is if someone says to you, you have some time to pay off some technical debt, this is the kind of stuff you could do. But it's also, I think, maybe a way of, if you're not being given time to pay off technical debt, how you can chip away at it as part of your normal work, right? So if you, instead of making it worse. So if you write your new code in a safe, tested environment and well-structured, but it's hooked into the old code, instead of it being like a 6-month rewrite of all that old stuff, then that's a way of actually just gradually improving your understanding of the code base and improving the actual code base as part of your daily work. You know, like some of the kind of big beasts of the agile movement or the software craftsmanship movement would say it's part of our job as programmers to be professional. And that means doing this type of work as part of the tasks that we're given, rather than asking for permission for, please, can I go refactor something? It's like, yeah, part of my job is slowly improving stuff while I'm doing these other things.
Now, while you're slogging through this spaghetti, how can you keep a positive mindset?
I think the best way that I know of is to always be aware that you're making forward progress or find ways that you can see forward progress. So whether that is fixing small issues, adding a test, getting PRs merged, whatever that small little incremental progress is, the more incremental progress you can see, that'll keep the motivation, keep the positive attitude as you're working through what can be a slog.
Yeah, I think a lot of what we've been saying is partly these tricks to kind of hack your brain to feel like you're making progress. If you put in a little pull request that is a rename of a variable, then your colleague's going to be able to review it really easily. You're going to get that merged. It's safe. And you've just made a bit of a difference today.
And you get to see the green merge check. That's a little hit of dopamine right there.
Yeah, and your manager gives you a pay rise because you merged code, right?
Yeah, so things like adding tests, that those metrics can go up and that can be positive. But one of the things that I like to do is creating all the different like PR stacks or branches with all of these various fixes as I'm going through the code. And that alone, I consider a positive dopamine hit to see like, oh, hey, there's still these branches that I want to do. These are all things that I plan on doing to improve the code base. Those all help me because it makes me feel productive. I feel like I have a lot of different directions that I can go and different things that I'm doing to improve the code.
Yeah. And yeah, have a little thing you're working on in the background that makes stuff better, even if you're working on something horrible that's making stuff worse. I also think I really like the stuff Kevin's saying about making sure you can measure things, right? So if you measure the test coverage or measure something that is going to get better over time and then give yourself a little reward in your head or give your team a reward by saying, look, we made the test coverage better this week or some other metric if that's not the right metric for, like, think about what you want to be better and then whether there's a way of measuring it.
I mentioned the thing about paying off your technical debt, and asked if that's what you were basically saying. And you very diplomatically, Andy, said, maybe, as in no. But what we are talking about here is technical debt, isn't it?
Yeah.
One of the things I like about the term technical debt is, although in software engineering, it has a negative connotation. It's always said with, reasons for rewrites and reasons for refactors. However, debt in, I think, just the technical sense, you can take on debt for good reasons. You can take out a loan to help you build a business or to do something to grow. Now, you absolutely need to be mindful of how much debt that you've taken out, and you do need to take steps to pay it back, as we're talking about today. But debt in and of itself can be a positive thing. It can be a way to make progress forward, to make something better in the short term so that you can extend it into the long term.
I feel like that analogy also holds true with that scenario I was describing earlier, where you have, on the one hand, the big change that makes the bigger picture better, or the small change that is incremental progress, but might make the overall picture a little bit worse. That might be an example of changing debt from one provider to another or something. I don't know. Refinancing, I guess, is the term.
Paying off one credit card with another credit card.
Yeah.
Yeah, I think you're right. Like that, and I think that would be quite a constructive way of thinking about debt, of like, I've decided to do this evil hack because it's on the path to better code. I actually think what you said, Kevin, is one of the reasons why I think technical debt is a dangerous phrase to use. Because the thing about debt is it doesn't slow down your work. Whereas often when we're talking about technical debt, I think of it a bit more as like letting grit build up in your machinery or something. Like there's a risk of total system failure, but there's also it just slows you down when you're trying to make forward progress. And so one of the tips I would say about handling technical debt, especially if you've got management who are not interested in hearing, we need to fix this thing because it's not very good, is to explain why things are slow, right? So it took me a long time to do this because I spent the first week just understanding how this code works, or this code is really hard to change because it's tied to X or Y, whatever it is, like explaining the consequences of technical debt and saying, okay, that fairly simple change that we want to make next month is actually going to take the whole of next month because I happen to know that bit of code is really awful and we're going to have to work harder to make progress there. So that's like the meta-narrative of it. Like, so I guess the assumption there is you definitely should fix your technical debt because you will go faster and be happier. But if you've got people who don't want to hear that, then that's the way to like explain why it's a good idea.
Well, if you've got any thoughts on all of this, you can email us, show@linuxdevtime.com. But we'd better get out of here. We'll be back in a couple of weeks. Until then, I've been Joe.
I've been Amaleth.
I've been Kevin.
And I've been Andy.
See you later.